this video, we will be learning how to draw Lewis structures. Now, this method allows you to come up with a structure given a molecular formula. Suppose we want to find the structure for carbon dioxide. So what is the molecular formula for carbon dioxide? It is CO2, right? 1 carbon and 2 atoms of oxygen. Now, the first step in drawing the Lewis structure is to count the total number of valence electrons available. Now, the electronic configuration of carbon is 1s2, 2s2, 2p2. So the outermost shell is the second shell, and the total number of valence electrons is 2 plus 2, which is 4. Similarly, for oxygen, the electronic configuration would be 1s2, 2s2, 2p4. So the total number of valence electrons is 2 plus 4, which is 6. So the total number of valence electrons in carbon dioxide would be 4 plus 6. But we have 2 oxygens, so therefore we multiply the 6 by 2. So this is 4 plus 12, which is 16 electrons. Now, the second step would be to draw the atoms in a straight line with carbon at the center. Usually we draw carbon at the center of a chain. Now, why did I say to draw it linearly? Because we have 3 atoms. There are other configurations possible, but we will keep it simple for now. So we have oxygen, carbon, and then oxygen. So now we have to draw a total of 4 items around 1 atom. And that is because these atoms follow the octet rule. They want to attain a total of 8 electrons around them. That is an octet. Now, first, to start this structure, we have to make 1 bond between 2 atoms. Like there should be 1 bond between oxygen and carbon, 1 bond between carbon and oxygen in the next one. So this is like the least that we want. Now we have to give a total of 8 electrons to each atom. So to do that, let's draw the lone electrons. The carbon already has 4 electrons because in 1 bond there are 2 electrons. So there are 2 bonds, so there are 4 electrons, and then we give it the other 4. So it has 8 electrons now. Oxygen has only 1 bond right now, so it only has 2 electrons. So we give it the other 6. And then same with the other oxygen. Now we have to count the total number of electrons that we have used. So the used electrons, there are 6, 7, 8 by 1 oxygen, and then 8 by the other oxygen. So 16, 17, 18, 19, 20. We have used 20 electrons. Now this is way higher than what we have right now. We have 16 electrons and we have used 20. So 4 additional electrons have been used. But we have to reduce this number in a manner that there is minimum formal charge on each atom. So to do this, you make 1 more bond between any 2 atoms. Of course, keeping in mind the formal charge consideration. And if you are not familiar with how to calculate formal charge, you can check my other video for formal charges. Now, the formal charge on carbon, like in this structure, although it would not be the correct one because we have used more than the needed electrons, but if we had to calculate it, it would be 4 minus the number of bonds, which is 2, minus the number of electrons, which is 4. So this is -2. And on oxygen, it would be 6 minus 1 minus 6, which is -1. So right now, we don't have the minimum possible formal charges, so we know this is not the correct structure. And also, more electrons have been used. To do that, we draw one more bond between any two atoms. So again, let's consider this, and let's make one more bond between these two. And let's keep it 1 here. Let's see if we have done anything to it. So 2 more on this, 1 pair, and then same. So now we have used 18 electrons. But again, we only have 16 electrons, so we have used 2 more. So to compensate for that, let's again make one more bond. So we have 2 bonds now. And carbon has 8 electrons because it has 4 bonds. Oxygen needs 2 more, and the other one needs 2 more. And now if you count the total number of electrons, 16 electrons have been used. And if you calculate the formal charge for carbon, it would be 4 minus 4, which is 0. And for oxygen, it would be 6 minus 2 minus 4, which is 0. So these are the minimum formal charges you can attain. So therefore, this is the structure we want. This is the structure of carbon dioxide molecule. Now let's do one more. Let's do sulfuric acid. So what is the molecular formula? It is H2SO4. The number of valence electrons would be 2 times 1 for the hydrogen, plus 6 for sulfur, plus 4 times 6 for oxygen, and this comes out to be 32 electrons. Now, how I got the number of valence electrons is from the electronic configuration. And if you are not familiar with how to write an electron configuration, you can check out my other video for electron configuration. So now, let's make a structure for sulfuric acid. So we keep sulfur at the center. Usually hydrogens, they are terminal atoms because they only need one bond. So they are terminal atoms. So let's keep sulfur at the center, and then 4 oxygen, so we can put it like this. And then 2 hydrogens, so you can place it with any 2 oxygens. Suppose I place it here and here. You can place it on any of the 4 oxygens. So now let's give them one bond each. So there you go. You have one bond between any 2 atoms. And now let's give them the octet. So to do that, sulfur already has an octet right now. And then oxygen here will need 3 pairs. And this will also need 3 pairs, 2 pairs, 2 pairs. And hydrogen does not need an octet. It needs a doublet. Means only 2 electrons. Now, if you count the total number of electrons that have been used in this structure, it would be 32 electrons. But still there is a problem with this structure. And the problem is that the formal charges on the atoms are not the minimum formal charges you can get. For example, the formal charge on sulfur right now is +2, and the formal charge on oxygen, let's give them numbers here. This is 1, this is 2, 3, and 4. So the formal charge on oxygen number 1 is 0, which is nice, and this is the same as the oxygen number 3, but the formal charge on oxygen number 2 is equal to -1, which is the same as the formal charge on oxygen number 4. So these are not the minimum charges you can get. Sometimes these are the minimum, but here we can get a better structure. Now, how can we get a structure with a lower formal charge now? According to the formal charge formula, you would notice that sulfur needs 2 more bonds. Or you can say it needs 2 lone electrons to get a formal charge of 0. And oxygen, it needs 1 more bond to get a formal charge of 0. Now, because both of them, the necessity which is common is that of a bond, so therefore we will choose that option. Now, how can we do that? We can make 1 more bond between oxygen and sulfur. So let's draw this. Now you would be wondering that why in the world does the sulfur have a total of 6 bonds around it? So now that is something that you will need to know. So let's draw the lone electrons first. Now if you notice on the periodic table, sulfur is in the 3rd row, right? It is in the 3rd row, or you can say it is in the 3rd period. And in the 3rd period, that means the 3rd shell has been used. And what are these subshells in a 3rd shell? It would be S, P, D. So how many maximum electrons can sulfur take? It can take 2 plus 6 plus 10, which is 18 electrons. So therefore, sulfur can take more than 8 electrons. Therefore, we have given it a total of 6 bonds around it. It does not have to follow the octet rule. So now if you count the total number of electrons that have been used, that would be 32 electrons. But the good thing now is that the formal charge on sulfur is 0, and the formal charge on each of those oxygens is 0. And that is what we want, right? Therefore, this is the structure that we want for sulfuric acid. I don't know why I keep on saying sulfur, but yeah. So thank you for watching. And if you want to learn how to calculate formal charges, or you want to know how to write electronic configurations, you can check my other videos. Thank you.